Okay, section 7.4 is really like an algebraic section. We are going to take rational functions, fractional things, and we're going to rewrite them into what's called partial fractions. We're going to break the ugly, nasty thing into smaller little pieces. To do this, we often use a system of equations to solve for the pieces that we need to write the partial fraction, which is why it's right after the solving section. However, this is really just an application or a skill that you need, especially in upper level math and calculus, when you're trying to integrate or differentiate really nasty things. And if you can break them into smaller, nicer, little cuter pieces, it makes your life a lot easier. So let's jump into some examples. Okay, so our first example, which is on the first page of the notes as well, says x plus 7 over x squared minus x minus 6. We want to break this into smaller partial fractions, and in this case, because the degree of the denominator is 2, we're going to break it into 2 smaller fractions. So the first thing we need to do is we need to factor the denominator. So let's do that. We have x squared minus x minus 6, which we know or should know factors into x minus 3 and x plus 2. So now that we have it factored, we're going to rewrite our original fraction, but into smaller pieces. So we can rewrite this as some letter a over my first factor, x minus 3, plus some letter b over my second factor, x plus 2. And when you add these two fractions together, it will have to equal x plus 7 over my x squared minus x minus 6. So to prove to you or show to you that this would work, if I wanted to undo what we just did, I'd have to multiply this by x plus 2 over x plus 2. And I'd have to multiply the next piece by x minus 3 over x minus 3. And then when I did that, multiply it all out, then I would get my final answer, because what I'm doing in blue and red is finding common denominators. So I want to take that and rewrite this. I know that a times x plus 2 plus b times x minus 3 has to equal my numerator on the other side, because when you add fractions, you add them together straight across to equal the numerator, x plus 7. So some key values that we want to take note of right here, key values. X equals negative 2, which I got from right here. That will make that factor go away. And I could do 3, because that'll make this factor go away. Now this equation right here holds true for any x values, but these very special ones will make things clean up nicely for me. So let's look at that. So what I'm going to do is I'm going to plug in these key x values to help me solve for a and b, so that I can go back and write this right here without the a and the b in it. So first, we're going to let x equal negative 2. And I'm going to use this statement right here. So I'm going to do a, negative 2 plus 2, plus b times negative 2 minus 3 equals negative 2 plus 7. So this is going to become nothing. B times a negative 5, negative 2 minus 3 is negative 5, equals 5. And now we know that b equals negative 1. That was super helpful. So now I know b. So that means 2. If I let x equal 3, I can find my a value. So we're going to do the same thing again, only we're going to let x equal 3. So a times 3 plus 2 plus b times 3 minus 3 equals 3 plus 7. That goes to 0. I get 5a equals 10, so a equals 2. That was super helpful also. So now I can go ahead and write my fractional decomposition in its final form. So I know that a is 2, so I have 2 over x minus 3 plus b was negative 1 over x plus 2. And these are my partial fractions that decomposed the x plus 7 over x squared minus x minus 6. So these things right here are your final answers. So let's try another example, but maybe a little bit more difficult. So example 2, we're going to do x to the 4th plus 2x to the 3rd plus 6x squared plus 20x plus 6, all divided by x cubed plus 2x squared plus x. So this one's more difficult because we have to simplify. We have to simplify first because this is an improper fraction. So just like when you learned about fractions in 4th grade, if you had something like 5 over 3, that was an improper fraction, and you would change it into a mixed number because 3 goes into 5 one times with 2/3 left over, and that would be a mixed number. If you look right here, my degree on the top is bigger than my degree on the bottom, so this is an improper fraction. And so the first thing I have to do is pull out my long division skills, and I'm going to long divide this polynomial. So I have to divide the denominator, the x cubed plus 2x squared plus x, don't forget your missing term, plus 0, into my numerator, x to the 4th plus 2x to the 3rd plus 6x squared plus 20x plus 6. So to make the x cubed look like x to the 4th, you have to multiply by an x, and we're going to line that up and put it over our x terms. And then you multiply x times x to the 3rd is x to the 4th. X times 2x squared is plus 2x cubed. X times x is plus an x squared, and then 0 times an x is 0 x's. Remember, when you're doing this, you subtract the entire quantity, so you have to distribute that negative sign all the way across the parentheses and change all of their signs. And so when you do that, the first terms cancel out. Luckily, our second terms cancel out. 6x squared minus an x squared is 5x squared. 0 minus anything is the other thing, so plus 20x. And then drop down the plus 6. Now you can see that this degree on the denominator will now be smaller than that x cubed. So if I rewrite what I have the 1x from the top right here. So I can write this as x plus 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x. Now in my fraction, you can see that my degree of my numerator is smaller than my denominator. So now I am not an improper fraction anymore. Now we can go back to doing fractional decomposition. So when we do the fractional decomposition, we are doing it with this piece right here. Okay, so let's do that. So I'm going to hold on to my but remember, my first math step in fractional decomposition is to factor that denominator. So I need to factor this thing right here. I can pull a GCF of an x out, then I get x squared plus 2x plus 1. That's not completely factored, so let's try one more time. I have my x plus 5x squared plus 20x plus 6 over x times this factors into x plus 1 times x plus 1. So I can write that as x plus 1 squared. Now I'm finally factored. Okay, let's start this fractional decomposition. So here we go. One thing to note, I am not going to lose this x. I don't need to decompose the x. It's not a fraction, so I'm just going to hold on to it and leave it for a second. And what I really want to decompose is the other piece. So the other piece is the 5x squared plus 20x plus 6 over x times x plus 1 squared. So when I write this, the degree of this denominator is 3. So I'm going to have 3 pieces this time. And so when I do this, I need to write it broken down into all simple factors. So one of my factors in my denominator is an x, plus another factor of my denominator is an x plus 1, plus the last version of my factors for my denominator is not just the x plus 1, but the x plus 1 squared. So this is my a, my b, and my c. Now if I go in here and I want to prove to you or undo the math I just did, this fraction would have to be multiplied by x plus 1 squared over x plus 1 squared. This fraction needs the x times an x plus 1. We're always trying to get back to this denominator right here, times an x plus 1. And then this fraction needs an x and an x. So if I want to rewrite this, my 5x squared plus 20x plus 6 has to equal a x plus 1 squared plus b x plus 1 plus c times x. Now the critical key values of x they occur again from right here in this denominator. What happens when you let x equal, or when you let the denominator equal 0? So my key values of x are x equals 0 and x equals -1. So we're going to plug those in one at a time and solve for our variables. And we're plugging these in to this equation right here. So let's do that. So first, let's do x equals 0. So if I do that, I get 5 times 0 plus 20 times 0 plus 6 equals a times 1 plus b times 0 plus c times 0. This piece goes away, this piece goes away, this goes away, this goes away. So we have 6 equals a. Oops. 6 equals a. So that's one thing I need to hold on to. If I do this again and let x equal my -1, I'm going to get 5 times 1, because -1 squared is 1, plus 20 times -1 plus 6 equals a times 0 plus b times -1 times 0 plus c times -1. 0 times anything is 0, gone, and right here I wrote a -6, then a -1. Okay, so this is a 5 plus a 6 minus a 20. So this is going to be -9 on this side equals -c. Well, we now know that c equals 9. Okay, I don't know b though, and I've exhausted all my key values of x. So at this point in time, what we do is we pick any number for x we want, because this equation, that blue thing that I wrote right here, it should hold true for all values of x. So we're going to pick any value we want for x, and when we do this, we have to plug in our other key values that we found. So I'm going to go back up here, and I'm going to plug in a equals 6, c equals 9, and then we're going to pick an x. Don't pick 0. I mean, I know x already equaled 0 once, but in general, plugging in 0 is not great. I'm gonna pick an easy one though. So if we pick an x, let's pick an x of. Okay, so we're gonna go in and pick any x, and we're gonna plug in the x, or the a is 6 and c is 9. So let's make our lives easy. Let's pick x equals 1, because 1's an easy number to plug in. So I have 5 times 1 plus 20 plus 6 equals a is 6. 1 plus 1 is 2 squared plus b, x is 1, and then 1 plus 1 is 2, plus c was 9, and then x is 1. So let's clean this up a little bit. So this is going to be a 9 plus 2b plus 424. And on this side, I'm going to have 31. And so this and this make 33. So if I subtract that over, I get negative 2. It's going to equal 2b. So b equals negative 1. And now, after all of that work, it was so much work, we can write our fractional decomposition. When we write this, remember that x that I circled in green earlier that I said, do not lose this? Well, we can't lose it. So we're going to write x plus, it was a, and my a is 6 over x, plus then I had b, which is negative 1 over x plus 1, plus then it was c, 9 over the x plus 1 squared. This is the fractional decomposition of that original problem that we had.